Greetings and welcome back. Today we're going to be looking at an introduction and how to name carboxylic acids. As a reminder, carboxylic acids have a C double bond O, OH, all coming off of that same central carbon. They are acidic. The reason, as you may recall, that they are acidic is that, and this is going to be your entire introduction to them, when they give away that hydrogen, their conjugate base looks like this, and that guy has resonance in which it can move its electrons back and forth between the two oxygens to share that negative charge, and therefore we end up with something that is the most acidic of really all of our kind of standard functional groups. And that's why the name of it is a carboxylic acid. So both of those oxygens basically have a -1/2 and a -1/2, so that makes them pretty happy and pretty stable. Alright, that's your introduction. So let's talk about naming them. The way that you name a carboxylic acid is you drop the last E at the end of the word, and you replace it with oic acid. 2 words. So for instance, if you had a 4-carbon carboxylic acid, and don't forget to count the carbon that is in that chain, so or the one that's in the carboxylic acid. So this would be 1, 2, 3, 4. So again, the total number of carbons. This guy would be a butane chain, so instead of being butane, it will be butanoic acid. So butanoic acid is the name of this guy. We never have to worry about numbering because this will always be at carbon number 1. This is the highest priority functional groups of all functional groups. So if you're keeping track, this one isn't just higher than the ones we've done before. This is the highest of them all. So this is always going to be your number 1. Therefore, there is no way to name these as a substituent because they will not be a substituent. They will always be the highest priority functional group. Just like we did with carbaldehydes, there is a way to, let's say if you were drawing this guy out. That is not a benzene ring, that's a cyclohexane. So if you have that 1-carbon carboxylic acid, because the main chain here technically would be 1, what we do with that one little group, just like the carbaldehyde, we just use the term carboxylic acid. So if you recall, we basically give this guy a pseudo main chain name, so that would be cyclohexane. And then you just stick the word carboxylic acid at the end. Alright, and that's about it to naming carboxylic acids. There are some diacids, which we can talk about, and also some common names of some acids, which we can talk about. So I'll do the common ones first. The ones that you need to know are formic acid, and acetic acid, and benzoic acid. All of these have come up one way or another in class already. Formic acid would just have 1 carbon, so no one ever says methanoic acid. It's called formic acid. Likewise, acetic acid is the 2-carbon version, and no one ever really says ethanoic acid. Just say acetic acid. Benzoic acid is just with the benzene ring. And that is the name of that guy. So those are 3 common names that you need to know. Once you get to 3 and higher carbons, that's where we name them using this IUPAC. So propanoic, butanoic, pentanoic, hexanoic, etc., etc., etc. But for the little ones, these are actually common names. These are very commonly used, and no one says methanoic or ethanoic acid. We've looked at a 4-carbon chain with 1 carboxylic acid, which was butanoic acid. So let's look at a 4-carbon chain with 2 carboxylic acids. Which would be this guy. Again, don't forget that we have to count the carbons that are part of the carboxylic acids. So even though there's only 2 CH2s in between, this is 4 carbons in a row and both sides have a carboxylic acid on them. So the way that we've done done two groups in the past is use di. So dial was two aldehydes, diol was two alcohols, dioxo was two carbonyls, dimethyl, etc., etc. So we use the same thing here, which is that we use dioic acid, because oic acid is the way that we name carboxylic acids. So this would be a butane dioic acid. You can see that we have the di because there's two, oic acid because it's two oic acids. We have that little extra E in there, and as we've seen several times, IUPAC naming doesn't like to have two consonants in a row, so it's instead of butandioic acid, it's butane dioic acid. And then if you had substituents at carbons 2 or 3 or whatever, you could put them in. The reason that we don't have to put numbers is because this is the highest priority functional group, and when we had one of them, it was always at position number 1. If we've got two of them, they must be at positions number 1 and then the other end of the molecule. So we never worry about numbering with carboxylic acids, whether it's 1 or 2 carboxylic acids on the chain. All right, so the reason that these dioic acids are actually very important to biology is that every single step in the citric acid cycle, which is a major pathway in our metabolism, involves molecules that have multiple carboxylic acids. All right, so let's give you guys some to practice drawing. Here is, there's a common name of this. This is GABA, gamma-aminobutyric acid. That is not the IUPAC name, so please give me the IUPAC name of that. Also, I'd like you to do that guy, and that guy right there. All right, and we'll talk about those in class. All right, have a good afternoon or morning or night or whenever you're watching this, and I'll see you soon.